2021. You're here at Covestro, which is our North American headquarters in Pittsburgh, PA. For those of you from the region, if you go a little bit west into Robinson Township, that's where you'll find our location. We have a really fun and exciting tour this morning where you're going to hear from our professionals. We're going to go into a lab here in a little bit. But before we do that, I just want to tell you about Covestro and what we do as a company and how we work with our customers. So Covestro is a global leader in high-tech polymers. And we are a supplier to a lot of our customers. And what we do is we make the world a brighter place through finding solutions through real life problems and everyday life things. So you can see some products here that are behind me, things that go into automotive, things in your home, things that you interact with on a daily basis. We provide those materials to our customers, and then they manufacture the products that a consumer would eventually buy way down the road. And so what we're going to do today is we're going to go into one of our lab areas. This building in particular is a polyurethane technical center. And so we do a lot of research and development here, a lot of testing on our materials as well. We're going to hear from some of our scientists experts on how they interact and work with foam in particular. We're going to learn about rigid foam a little bit. We're going to see some stuff about flexible foam. So you think about things that are in your automotive seating, in your bedding, in your furniture. Those are the types of materials we're working with here today. So as we go into the tour here, you're going to learn a lot of different things. We have laboratories and machine areas here, and our scientists are going to explain those things a little bit better to you guys, much better than I can. So let's go ahead and get started. We're going to introduce to you some of our scientists. So follow me on down to the lab area, and we'll get started. As we progress our way down here through the lab, you'll see one of the first things we have is safety first. So we want to make sure that we're wearing the right personal protective equipment. So I'm going to make sure I have my safety glasses on as a guest in here, and then we're going to go right into our lab area. So now that we're in our lab area, you can see there's a lot of pipes and valves and things going on. This is just a very small part of our facility here. And what we're going to do is we're going to head down this direction here. These are all laboratories that we have on the side down here where our scientists are working on what's called a bench scale. So they're doing small experimental runs and tests of our materials. And then as you'll learn throughout today, we're going to scale that up. We're going to take something small and we're going to go a little bit bigger, and then eventually what would go to a full-scale production. So one thing I want to mention to you all is that since we're live streaming today, if you have questions whatsoever, feel free to send those online, and I can ask questions to our professionals in a live manner. So feel free to do that. I'll be checking those as we go through. But let's go ahead and head down and meet some of our first scientists. Oh, here they are now. They're going to wave us in. All right, come on in. Let's go check it out. Hey, so this is John and Michelle. They are two of our scientists, and we are in their lab area. Thanks, guys, for letting us in here. Can you tell us a little bit about what you're doing today?
Sure. So this is one of our polyurethane foaming labs. So it's where we kind of first get an idea of our foam reactivity and performance before we scale up onto our larger stage. So basically, if a customer is having an issue with their current foam system, or if they have a new application they want us to develop a system for, we can work in our labs to make sure that we're coming up with a system that will fit their specific needs. So if we boil down polyurethane into a really simple form, it's basically the combination of an isocyanate and a polyol resin together to form a polyurethane. So we have here at Covestro so many options for polyol. Do we hear any of that? No?
Yeah, back up a little.
All right, where are we starting from?
They're back.
Okay, so we're in our polyurethane foaming lab. Sorry about that. We're telling it's not IT, apparently. So what we do here in the lab basically is if a customer is having an issue with their foam system, or if they have a new system that they want us to develop to fit a specific need, we can get to work here in our lab to develop something that will fit their needs. So on a smaller scale, we can do things like create activity cups or lab scale molding to get an idea of how it will behave. A polyurethane in its most basic form is the combination of an isocyanate and a polyol resin. So here at Covestro, we have a full range of polyols to choose from, and also a full range of isocyanates. So our major task here in the lab is figuring out which of each to use at what ratio to give the customer the foam product that they're looking for. And I was saying that one metaphor I like to use is that it's similar to baking cookies from scratch. So if you bake your cookies from scratch the first time, you might find that they're a little too chewy for your taste or not chewy enough. You got to go back in there, use what you learned to create something that will fit your exact taste.
Yeah, that's pretty cool. So I understand you guys make different types of foams here. Can you tell me a little bit about the difference between flexible foam and rigid foam?
Yeah, absolutely, Ben. So as you said, there are two different types of foams that we focus on here at Covestro. We have rigid foam and flexible foam. Rigid foam is a lot harder, stiffer, and flexible foam is compressive and soft. So like Michelle said, we have a lot of different polyols and isocyanates, and what we like to say is that formulation dictates function. So the amounts of isocyanate versus polyols that we use and the different types that we use make a huge impact on flexible versus rigid foam. For our polyols, they're like chains, and they come in different sizes, which we measure in molecular weight. So the longer the chain, the higher the molecular weight, and the shorter the chain, the lower the molecular weight. Longer chain, high molecular weight polyols are more flexible and a little easier to work with, and shorter chain polyols tend to be more rigid. So if we wanted to make a flexible foam, we'd use longer chain, high molecular weight polyols, and if we wanted to make a flexible foam or a rigid foam, we'd use shorter chain, lower molecular weight polyols. Also, the isocyanate plays a huge role, and the amount that we use is really important. We call isocyanates the hard segments, and that leads to a more rigid foam. So if we want to make rigid foam, we'd increase the amount of isocyanate that we use. If we want to make a flexible foam, we'd use less isocyanate.
We also have something that we call an additive package that's in our polyol resin. So this is something that contains things like our catalysts, our surfactants, our glowing agents, pigments. There's a whole range of things that we can add in to fit the specific needs of our customers. So while these additives make up a small percent of the overall formulation, they play a huge role in fine-tuning our system to meet the specific needs. So today, one of the things that we're going to do here in the lab is called a P-rise reactivity test. So this is a pretty simple and easy test that we can do to get a first idea of our reactivity and some of its initial properties. All right, John, you want to tell them why we care about reactivity?
Yeah, so reactivity is extremely important for making foam at a much larger production scale. So when our customers are making foam with our products, they really need to know how long it's going to take for the foam to fully react. Some of our customers make molded foam. So they put foam into a mold, and then they close the lid, and the foam reacts within that mold. And if it reacts too quickly before they can close the lid, they're going to be spraying foam outside their mold all over the production site. It's going to be a giant mess, and they're going to be really unhappy. If the foam doesn't react fast enough, when they go to open that mold and they expect to take the foam out, it's going to be a gooey, gross mess, and it's just not going to work well for them. And they want to make as much foam as fast as possible, so they need to have that timing just right.
So the specific method that John's using today, he's looking for the final cure of the foam, so the time whenever it aren't sticky anymore, which is important to the customer. He's also going to be looking at the amount of heat that's released in this reaction, or what we call the exotherm. And finally, we can take these foams and look at things like density and the overall feel of the foam to make sure that we're aligning with what the customer wants. If we get an idea that we're on track to what the customer is needing, that gives us a good idea that we can scale this up to a larger system. All right, John, are you ready to show them how it's done?
Yeah, exactly. So before we make anything in the lab, the number one thing that we're always concerned about is safety here. So I have my lab coat on, which will protect me from any foam. I also have safety glasses. Furthermore, for these foams, I'm going to be wearing a face shield, And I need to wear gloves. We also do all of our experimentation in a lab hood here. This keeps all the any fumes that might come out, they get sucked up into the hood. So what I'm going to be doing is a free rise reactivity cup, and I have my my polyol here. It's in this cup. It's a sort of thick white substance, and I'm going to be weighing out and pouring in isocyanate. It's a syrupy amber-colored substance. So I'm going to weigh that and pour that into the cup. And then I'm going to mix it together here under the blender, and I'm going to start my timer. That timer is going to give me the time that it reacts. And then I'm going to measure with a stick to see how long it takes for it to cure. And while I'm doing that, here we have a thermoprobe. A thermoprobe is a fancy thermometer that will actually measure the internal temperature of our foam. And it has a wireless connector here that's connected to the computer behind us. And that's going to measure and collect all the data from our reaction. And then we can analyze that data later. So this is pretty quick. So I'm going to get going here.
So it's just like that, huh, John?
Yeah, just like that. And as you can see, it starts to rise and it starts to fluff up. That's a good sign that we're making a good high quality foam. But as you can see early on, it's still not cured yet. So we have to wait a little and see if it's going to cure up in the right amount of time.
And so, John, what properties are you looking for whenever you're doing this test?
So we make sure that the foam no longer sticks to the popsicle stick here. That gives us our what we call tack-free time. Tack-free meaning that it's not tacky anymore, and it's hard. We're getting pretty close, and I bet in just a few more seconds, yeah, it's no longer sticking to the popsicle stick. So that's pretty good. It's about a 55-second tack-free, and that's usually what we look for our customers. So.
That's awesome. So you talked about temperature as well that you're reading on this gauge. So what's the technology? Can you show us a little bit about that too?
Yeah, so like I said, the thermoprobe over there measures the internal temperature of the foam. And here on our computer, you can see this red line was measuring the temperature. And since we started the foam reaction, it heats up. And that actually causes the temperature to rise here. And we measure this, and then we collect it, and we have a digital data bank of all of our information where we can store it, look for trends, see how different foams react and compare different types of foams.
Yeah, and at this point, once we have our final clear foam, we can take it and submit it for more physical properties at our physical testing labs that we have on site. So while we can see things like our reactivity here in the lab, our on-site physical testing lab can do a lot more than we can do here. So they can measure things like our foam strength, compressive properties, even thermal properties, and how our material ages over time. We even have microscopes, so we can take a look at our foam cell structure on a super up-close look, which is amazing. So that's basically how we can make sure that our foam on the lab scale is behaving how we want before we scale up to our machine.
Yeah, so from here, since this formulation seemed to work well, we would take this to our next machine, which we would call the box foam machine. And it's similar to this, only it's about 30 times larger. The box is about as tall as I am. And they do very similar things. They just want to make sure that at an even bigger scale, the reaction stays the same. And they have a thermoprobe just like that, and they measure the temperature the same. And Ben will be showing you that in a few minutes.
Yeah, that's pretty cool. So we're gonna see a quick clip of that here in a minute, but I want to ask you guys a couple other questions. So this foam that you're working with, what are some real world applications where this can go into?
So it's funny because one of the main things that we say here is that our foam goes to pretty much everything around you that you can touch. So you can go into things like the seat of your car, to the insulation in your walls, even the mattress that you sleep on. And it all kind of depends on the formulation, like we were saying. Depending on which types of polyols you choose and at what ratios, you can make a whole range of products. So you'll actually be seeing later on in the store, one of our larger examples, we can make mattress foams.
That's perfect. Thanks for explaining that a little bit further for us. So right before we go, I also want to get the audience to get to understand how you guys got to where you are in your career. So can you just share a little bit about your background, your pathway to Covestro a little bit too?
Yeah, absolutely. So Michelle and I are both chemists here in the lab, and we both have bachelor's degrees in chemistry. And so we had to go to, college for 4 years. And if you wanted to get into the lab like this, a degree like chemistry, chemical engineering, polymer science, physics, or really anything in STEM would be the kind of right direction to go for to get into a position like this. And if you really are interested in coming to Covestro, I highly recommend looking into our internship experience. It's truly fantastic, and hearing about our trainee program as well is a great way to learn and grow.
Yeah, John and I actually both did the internship program here, our technical internship, and we also both did the trainee rotational program. So can definitely vouch for how helpful that is getting hooked on the polymer industry and Covestro specifically. And actually, I mean, after you finish your education, you don't have to stop once you start working. I'm actually currently enrolled in an online master's program for polymer engineering because I want to learn a lot more about the process side of things outside of the lab. So there's always something to learn.
That's awesome. Thanks, guys, for sharing, and thanks for letting us join your lab here today. So as we transition, you guys talked about the box foam machine. We're going to show a quick clip on that. So we're going to transition here to a video that you guys can see online of this box foam machine.
We begin in the lab, and when we discover things that are working in the lab, we scale it up to our box foam machine. And basically what it does, it shoots a box of foam, and the size of the foam is the equivalency of what we'd see in normal production. And we use this to measure various process and temperature effects. Once we get positive results from our box foam machine, we scale it up to our Minimax machine. We begin in the lab, and when we discover things that are working in the lab, we scale it up to our box foam machine. And basically what it does, it shoots a box of foam, and the size of the foam is the equivalency of what we'd see in normal production. And we use this to measure various process and temperature effects. Once we get positive results from our box foam machine, we scale it up to our Minimax machine. We begin in the lab, and we
so what they'll do, like these guys, John and Michelle were doing it here, is they'll take that small batch and they'll scale it up to a bigger batch after that, making sure that, they're not wasting materials, wasting time, wasting money, because you think about these materials eventually go into full production. And so we want to make sure that we're, making good efforts on the materials that we have here, not wasting money, not wasting time and materials as well. So that's why we do these tests. That's why John and Michelle start on a small scale, then we go to a box foam machine, and then we're going to show you the last machine on our tour, which is called a Minimax machine. So we have a polymer scientist expert. His name is Bill Gower. We're going to go meet him out in the labs, and he's going to walk us through this Minimax machine. So go ahead, let's go ahead and follow V, and let's see if we can track him down. So just so you know, as we're walking through this is all part of our Minimax machine, all these components, and Bill is going to talk to us about what every single part of these are. Oh, okay. I see Bill up here, so let's go ahead and talk to him a little bit. And we can learn a little bit more about this complex machine that we have here. All right. Hey, Bill, how you doing today?
I'm doing good. Thanks for joining me on this part of the virtual tour.
Yeah, absolutely. Can you share about this Minimax machine? I know there's a lot of complex parts to it, but you're an expert on this machine. You've been working on it for a long time. So I'd just like to hear a little bit about how this machine works.
Yeah, thanks for asking that. So my area of expertise and what this machine does, it makes flexible foam. So as they talked about rigid and flex and about soft versus firm, you can see this is a flexible foam. It's very squishy. This is actually a memory foam like you would find in a mattress on the top layer. So this is the kind of foam that's made on this machine. Now this machine will be the last step that we go through as we're going to take things to a customer. So if a customer comes to us and says, we're looking for this type of foam or this type of product, we start in the lab, box foam, and then we take it on to here, because this is the same machine that our customers would have, but on a quarter scale. So it has all the complexities of a production machine, and it can actually run continuously. As long as we have space or chemicals, we can continue to run this machine when it's up and running. We can actually do 5, 6, sometimes 7 experiments all in one run.
So that's why you call it a mini max, because this is a much smaller scale from a full production, yes?
Correct. So the production name would be a max foam machine, or the technology. So this would be a miniature version of that. So just to talk through and show you some of the complexity, if you follow me, I'll show you where everything kind of starts. So everything starts with the chemicals. As Michelle mentioned, she liked to use a reference of cookies. Here, we like to kind of reference cakes. It's more like a cake. It's big, it's soft, and it rises up. And you have to have the ingredients correctly in it, what we call a formulation or a recipe. And it all starts with the chemicals, which we have in these tanks. So these are the small tanks, and these are all the additives that she was talking about, things like your catalyst and your surfactant, things to help make the foam the properties that you want to have. And each individual tank has its own pump, has its own metering system. So we're able to very fine-tune and precisely control how the chemicals get into the foam. So once they go out of here, they go through these pipes. You can see all the pipe racks. They all work their way towards the machine. So if you also follow me, I'll show you. We also have, in the lab, they mentioned polyols and isocyanates. So those are a much bigger component. It makes up most of the, probably 95% of what the polyurethane foam has. And that's what these tanks are here. And they are exactly like the small tanks. They all have their own pumps. They all have their own metering systems here. And what's truly interesting is we talk about safety all the time and people overlook it. And you can see right here, we have things like this on every stream. And what this is a safety device. So all of our streams, all of our components have these safety devices that if it starts to get over pressurized, it just causes it to go in a little loop. So it's called what we call a pressure relief valve, a pressure relief device. So we take safety very seriously. And you can see with the complexity of all this, we have to really be monitoring a lot of different things. And so these all as well go all this way, this direction towards the mix head. So this is what we call the mix head, or this is where all the chemicals come together up here. So all those pipes send all the chemicals all through here, comes all the way to this point here, which we call a manifold. And this is where all the chemicals start mixing together. And from there, it comes to the mix head. There's actually a little mixer in there, kind of, I don't want to say like a blender, but it just basically blends everything together. Our isocyanate comes in up at the top, and then the actual mixed component or mixed liquid comes through this hose down into the trough here, and then it starts reacting. And when it reacts, it comes out as already partially foam. So what you saw happen in the box starts happening right here.
Okay, so Bill, I want to back up for just a second, because there's all these valves and these pipes that are coming in here, and you talked about these materials coming in. So does it matter what order did they come in? I mean, can one react before the other? Can you talk about that a little bit?
Yeah, that's a great question, because even in the lab, we have to be careful how and the order that we add components. So for instance, we know that water is used in this formulation, and the other thing we always use is a catalyst. That's a metal catalyst made out of tin. And they actually will cause each other problems. The water will cause the tin to not work. So because of that, we have to add the tin here at this point, and the water goes all the way in the back at the very farthest away. So we keep them as far apart as possible. And the isocyanate is one of the last components to come in as well, because that's what kicks off the reactivity, is when it mixes with all the polyol and the additives.
Awesome. So we see this big tunnel down here. Let's talk about what's going on inside of there. What happens in this tunnel?
Yeah, so as I mentioned in the beginning, this is a continuous machine. So as the chemicals start reacting in this and coming out, they fall onto this conveyor belt. and then it continues to move down. So we have the ability, we turn on the conveyor, it starts going down, and it starts reacting. Like you saw in the box in the lab or in the box home, that happens actually here while it's going in two directions, right? It's going down the tunnel, but it's also rising up. And while we're doing that, we have the ability to have all these different sensors here, so we can capture the temperature, and we can capture the height as we're going down. So we can actually measure the rise of the foam. So as they did in the lab, we want to see as well here on our machine. And when we do all that, it's all being controlled by our computer. It's not on now, but this computer actually controls everything. So we can actually put the recipes in there, 5, 6, 7, 8 of them. And then if we want to switch over while it's running, we just click a little button here with the mouse, and it changes all the chemical ratios, and we make a whole new different cake. So you can go from like a lemon cake to a chocolate cake, all right in a row.
So you're saying as that is running down there, you could just change at the click of a button. So you're getting different test runs whenever you're doing one of these buns here. And then what do you do with those buns afterwards? How do you test and further work on those?
Yeah, so that's a great question. So these buns, what we do normally is, like our customers, they'll cut them and put them in a bun room. We actually just leave ours on the conveyor. So you'll see that when we make a foam run, it'll go from here all the way down about, I want to say about 150 feet, 180 feet long. And we just leave it overnight to cure out, because that chemical reaction takes roughly 5, 6 to 18 hours, depending on it. So you need to make sure that continues reacting and all the chemicals are done. And then the next day, we actually cut them down into smaller test blocks. And from those, we're able to submit them over to the physical testing lab and find out the physical properties and make sure that it's meeting the requirements that our customers ask for.
Yeah, that's awesome. So you do a lot of the testing, and then what do you do with the foam after that? I mean, do you guys just throw it away, or is that something that you guys do with it?
Yeah, so that's another great question. So one of our big sticking points for foam is you get a lot of it and you don't know what to do with it. So being Covestro, we're green, we're circular, we're working towards a circular economy. And because of that, we take all of our foam. Actually, we have an agreement with one of our customers. They buy, or they don't buy, but they actually ship all of our foam to one of their plants in Texas. And there it's chopped up and turned into carpet underpads. So it's completely being reused and recycled. So that way, nothing that we make, we're trying to go zero to the landfill as much as possible.
Yeah, that's really great. So one more question up here, because I know you have some other parts you want to show us too. So you're right here next to the chemicals as that's working. So what kind of safety processes do you have up here?
Yeah, so obviously the first and most important is our personal safety equipment. So we have to have long sleeves, we have to have safety glasses, and actually while we're running, we're actually have a respirator all around our neck. So just in case something goes wrong, we can put that on to protect ourselves from our lungs. But then we also have engineering controls that are built in. So this has a ventilation system that whenever the machine is turned on, it's running. So therefore it never goes out. And if it goes out, even while we're running, the machine automatically shuts itself down to help protect everybody at that point. And then we also have these monitors here all the way throughout the building. So we have some over in our chemical area, we have some all the way down the machine. And this is constantly monitoring for isocyanates to make sure that we're not being exposed and that we're actually being safe and kept safe. Because the most important thing is you want to go home in the same condition that you came into work with.
Yeah, absolutely, Bill. I agree with that. So can we see down the tunnel a little bit more? You have another viewpoint for us?
Yeah, absolutely. Follow me. So as I mentioned before, now you can actually see what would be on that monitor up there. This is actually what it looks like from a standpoint. So we actually have a secondary monitor here. So the chemist can see over there while they're running. The operator, the one running the machine, looks at his screen. This gives us the ability to look at our screen. And as you can see, there's a lot going on, but one of the main things is we're capturing all of this data. We're looking at the flows. We're looking at all the different components going in, the pressures, making sure that nothing's unsafe and that everything's going in the way we want it to go in. And while the first thing we do is we look here and we see the formulation, we see everything's going in. Then we have an opportunity to come on up here And as you can see, we have plexiglass all along here. So we have the ability to actually watch the foam as it's rising and coming down. So I've opened this window, which normally wouldn't be open. So that way you're able to go in there and take a look. But we can see all the way down the tunnel. We can see the foam from the moment it starts to react all the way to where it's finished reacting. And that could take place anywhere between 15 feet, 13 feet, all the way down to even 29, 30 feet down in the tunnel.
So, Bill, I noticed that you're not running something today. Do you guys run frequently? Why doesn't this facility always have tests running?
So there's actually, that's a good question, and we ask ourselves that a lot too. There's different aspects to it. One is that we can't inundate our testing lab, because then things get backed up and then we won't get our results. So then we're slowed down anyhow. The second reason is we make about 7 or 8 data points, anywhere between 4 to 8 data points every time we run this machine. So we do get a lot of information that would normally take multiple foams in the lab. Another is just the sheer amount of materials, because you do want to try to minimize the amount of materials you're using, because again, all this foam has to go somewhere, and you can only make so much carpet on the pad, and we don't want it to go into a landfill. And the final reason is just trying to keep everything under control. So if you run a formulation, before you can go back and run again, you have to find out what the foam's like. So you got to go back, you got to test it, you got to look at it, and make sure that it's meeting the requirements. Otherwise, you're just running blind, and that's the one thing we don't want to do as scientists. We want to make sure we have a plan in place of what we want to do scientifically.
Yeah, Bill, I think those are really great points that you bring up. So the tests that you guys are doing are really important for a full-scale production facility. So would this be the next step after everything looks good on this test on the Minimax? This would then get shipped to a full-scale production facility?
So that's absolutely right. It's not necessarily shipped. We don't. So my job, which I didn't talk about, is actually application development, but I'm also tech service. So I go to the customers, and I'm one of the people that would go and scale this up. So that's actually the next step. We go to the customer. We go with our formulation and say, we think this is it. And they'll run small test trials on their production run, because as this is continuous, so is theirs. And at a cost of around $3,000 to $4,000 per minute, they don't want to run a long, unsuccessful trial. So we go there, they run these short trials, and they're able to get foam cut out of it, get tests done, and make sure that it's exactly what we want to have. And then we'll tweak it while we're at the customer as well.
Okay, yeah, that makes a lot more sense. And so once they like it, then we will produce more of it for them, yes?
We will produce the raw materials, correct. But if they want a modification to the formulation that we develop for them, then they'll ask for that, and then we'll come back and tweak it here. Or we might even tweak it at the customer if it's a small change in the formulation. So as we mentioned before, if you want to go from a lemon cake to a chocolate cake, it's pretty simple. We can do that at the customer. We don't have to come all the way back here and do it again. We just need to change 1 ingredient or 2 ingredients ratios and stuff like that. And just from an economy of scale, this machine, like we said, is 1/4 the size. So if you imagine we make a bun, and I'll show you in a minute, it's about 3 feet wide. Our customers are making buns that are 8 feet, 9 feet wide, and they could be as tall or taller than I am, 6, 7, 8 feet tall. So it's a lot costlier and a lot scarier if you make a mistake there than you do here on the lab or in the machine area.
Yeah, that makes sense. Can you show us one of these foam buns that you guys have made?
Yeah. I could show you a bun we made just the other day, actually. So when the foam comes down, then we have the ability, just like our customers do, to cut it. We have a cutoff saw that we can cut the foam down. So if you look here, this is just kind of an economy of scale here, that this is the size of what we do in the lab, and this is the size of the buns we make on the machine. And it's actually very similar formulation, and you can see one is much, much higher, bigger than the other one. So now imagine that at a customer, and they're making it at the scale I talked about, and they'll run anywhere between 1 mile to 2 miles worth of foam in a day, if you think of it in that term. So they're running 5, 6 hours. People have asked, well, why don't they run longer? Well, the biggest reason is space. You can see it takes up a lot of space, and you got to let it sit to cure out every day. So that's the biggest constraint for flexible foam in our business.
On LinkedIn, we have
Yeah,
100
that's
live
pretty
right
cool.
now.
That's pretty cool.
And
And thanks for sharing that with
Facebook,
us.
we have
Is there
like
anything else
20.
about this machine that you wanted to
YouTube, we
share
have
with us today?
15. Twitter, we have 20.
No, this is pretty much the whole scale of what the
That's
machine
good.
does.
I'm thrilled with that.
It is a great tool to have. We're very lucky at Covestro
And
to
over
have that,
time, so these will just
because
sit
I
at the top
know
of our feet
our
and more people.
customers don't have this. Very few of our customers have the ability to do small scale trials, and I don't think there's a lot of these out in the industry. So it's really helpful to have this kind of machine on site to be able to do this.
Yeah, Bill, thanks so much for showing us the Minimax here today. I'm sure there's a lot more details you could go into about this, but what I wanted to do next is just ask you about your background. You said a little bit about what your role is here, but how did you get to Covestro? I think it's always interesting for people to hear about pathways and how they get to where they are. So can you share a little bit about your background too?
Yeah, so just to start off, my background is in polymer science, polymer chemistry. That's where my formal training is. But as I always mention every time I've given talks to students in schools and high school, elementary school, is it's all about your skill set. It's what you want to do. So you figure out the skills you need to have the job you want. I've always loved problem solving, and I've always loved chemistry, because another saying I have is there's no such thing as a lukewarm chemist. They either love chemistry or they don't. And because of that, I love chemistry. So that when I come in every day, I'm really looking forward to coming in, because I love what I do. I love the chemistry, and I love fixing problems. I love working with customers, and I love developing new things. So what I've done over the years is I've ran a production line, so I got to learn these machines on a larger scale. I've worked for some of our additive suppliers, these smaller streams that we showed you in the very beginning, to try and really understand the chemistry and all the little nuances and specialty stuff that we do. And I even had a job with a customer or company that made a renewable product, because I feel it's very important that we look at the green aspect and the renewable aspect of things as well, because we only have so much petroleum, so we've got to constantly look at all these different things. And finally, I ended up here at Covestro because it's kind of a culmination of all my skills to be able to put to the test. I get to work in the lab, develop products, and then I get to go to the customers as well and help problem solve and troubleshoot.
That's awesome, Bill. Thank you. I appreciate that. So we're going to wrap up our tour here today. Again, I want to thank Bill and John and Michelle for showing us what they do in the labs, and then as we scale up and get so on and so forth. So those of you who are viewing online, I hope this kind of gave you an inside look into how products are made. You think about the things that you interact with on a daily basis. Think about stuff that you're touching in your home, in your vehicles, whether you play sports, anything like that. It all starts with the great work that these guys do to make sure that a product is going to work the way that it's supposed to. So I hope you think about that a lot more as you're going through your daily life, thanks to the work of these guys. I appreciate every single one of you who joined on this video call this morning. And if you're interested and want to know more about what Covestro does, you can check us out online, see our big portfolio of the materials that we make and what our materials go into as a final product. So thanks again so much for joining us. As a Covestro rep, we strive to make the world a brighter place. And thanks again for joining us today. And hopefully we'll see you next time.